The exercise I will present to you is the zip folder x03 underscore x04. You can download from the OSF exercise page of January 8th. And this project contains, as usually, the docs folder in which there are the notebook. The first one is it can be used to run the first simulation, a data formatter simulation. Data formatter is necessary because OMS has a standard for time series, special format. So when you have your own data, you have to use this one to prepare the time series to run inside the OMS. And the second running is about a simple simulation in which we read a time series and we pass this time series to a writer component that just save the new time series in a new file. Before running the simulation, I will present you the sim file, the simulation file. The first one is the data formatter. So here we define the resources path. That means that states where OMS can find the jar file. In our case, the jar file are contained in the dist folder. In the component section, we declare our component, the formatter. And the parameters section, we define all the parameters required by this component. So the first one is the path of the input data. The input data is contained in the data folder, and it is a CSV file. This CSV file has to be formatted in this way. So the first line contains a comma, and then you have some number that will represent the ED numbers of the station, of your measurement station. And from the second line, the time series start. So the first column is for the date, and date has to be formatted as year, line, the month, day. There is a blanket for, and then hour, columns, minutes, a comma, and then you have your data that refers to the other columns that you have in the first line. The second parameter that has to be set is the path for the output file. In this case, usually the output are stored in the output folder. But since this file is the input file for the following simulation, I prefer to save it in the data folder. Then there is the start date. You have to specify when your time series starts. The time step of your time series, the time step is expressed in minutes. So in our case, the data.csv file has a time step of 1 hour. So our time step is 60 minutes. The separator of the columns is a comma, and the number of columns before the data has to be 1. And no values data are marked with minus 9999. So we can now try to run the first simulation. So you can try with the Docker or with the OMS console. On Windows, here I specified the 2 commands. The first one for Linux and Mac, and the second for Windows. Now, when you have done, you can open.
I pushed to download it when you said where I can find it. It showed at the beginning time 12 minutes to download it. Now it's still 7 minutes.
Okay, so you don't have the project.
No, not yet. It is not.
Here I don't have a USB key. Maybe you can look from your. So everyone has finished with the simulation. So when your simulation is done, you can open the notebook 1E underscore data formatter. Yes.
If I download exercise 3 and 4, and inside I find the water tank, and it is yes, yeah. So I don't have those files.
Okay.
I tried again.
You try and it works.
No. So I mean, I'm trying it right now, but so it still seems that there is the water tank.
Yes, it's still working. Okay.
Any other?
I'm downloading now.
And the exercise component. Okay. You have to go to osf.io. This website here. No. Zeta.
I got the zip.
This is the website. Did you get the new, cioè hai preso l'ultima versione? L'hai trovata?
Versione 3.
Ok.
Sulla tua inizio sei fatti che si chiama extra 4. Poi inizio sono sulla tua inizio
Ah, ok. Ma questo dal blog di About Hydrology?
sto correggendo. I am modifying it.
Everyone is okay now? Okay. Okay. So in the meanwhile, I will show you the notebook then that we will use later. So this notebook 1E, it is just to compare the input and the output file of the data format simulation. So before we read the input data, and this is the header of this data frame of raw data. Then I open the formatted one and simply compare the two data frame, and Python returns true. This means that these files are the same. But what is important to see is that if we open with a text editor, the data formatter has added this header that it is necessary to run OMS simulation. The second sim file is a simple simulation in which we have two components. One is the reader and the other is the writer. The reader just read the formatted data, pass the value to the writer that saves this data in another file. The parameter for these two components are, for the reader, we have the file, that is the input file. So here we specify the path, and the input file is the data formatted. The ID field is, in this case, ID. Sorry. And this is this value here. This is a thing that allows OMS to identify the ID station of the ID of your measurement station, in this case 1 and 2. Then we have the start date, the end date. We can choose a time window that the important thing is that the time window we choose is within our input file. So we can start from the 1st of January, but we can also start from the 2nd. The important thing is that the date, the start date and the end date are contained in the input file. We have to define the time step and the no value for the no value. The writer, we have the path of the output. In this case, we save the output in the output folder. The writer requires the date of the start date of the time series and the time step of the series. In this case, we have also a connection because we have to connect the reader and the writer. So the output of the reader, the out data, has to be passed to the writer in data field. With the notebook 2, we can run this simulation. And at the end, the notebook 2e, with the notebook 2e, we can compare if the input data and the output data are the same. So first I read the input data, and then the output data, and Python tells me that the two data frames are equals. The next step is to try to create a new OMS project from using this information contained in this project. So the jar file, we can write together the sim file and then test our project. So I create a new project and I call it my x03 underscore x04. I enter in the project folder, and now I have to create some subfolders. First of all, I need the data folder to store the input data. Then I need the dist folder for the jar files. The output folder. I don't know why I have this problem. Output. I need the simulation folder. And finally, the docs folder. Everyone is okay? Can I go now? Can I go on? So now we can start to copy our files. I start with the data. So I take the data.csv and I copy it in the data folder. Then I have the dist, so I go back to the original project and I copy the jar files. I copy the notebooks. Sorry, I have some problem. Okay. And finally, I need the simulation file. Well, the simulation file we can create by we can rewrite them. And now I open the original one. That you need. So we have we need the data.csv, the jars file that has to be put in the dist folder. Data formatter and this one, data formatter.jar. You have? Sorry, in lib. Okay. You have it probably in list in lib folder. You have to put the jar file in the dist folder. In the dist folder. One more. You don't have. You have a data formatter JGT. But did you download the version 3?
Yes.
Because here I can see just the 2 one. Okay, but you don't have. You don't need the third one. And then so we can write our sim file.
Now we have to change because we have line 12.
Yeah, so you have to change it lib. We can. You have to change it to dist. So I copy the first line. Then we have to define the path of our jar files. Here the string OMSPRJ is defined as the home of the project. So we can use the variable home to set the local path of the files. So now we have the model. Now we have to compile to complete all the 3 sections. We define our components formatter.
Sorry, can you just repeat that whole?
Okay, because when you have to define the path of your data, instead of starting from C and put all the complete path, you can define the home, the project, the home the root of your project as a home. So you can use this variable to define the local path of your files. So I define the formatter component. And now we start to define the parameters. So I have the path of the input data. So formatter dot path input data. And here I can use the variable home. So I use the dollar symbol home, and then say that the input file is in the folder data, and the name of the file data.csv. Then I have to specify the output folder. So formatter. The variable is path output data. Again, I use the home variable. And I want that this output will be saved in the data folder with the name data underscore formatted .csv.
The name of the that form on the top should be the name of the project, or this is a standard OMS?
No, this is the standard. You have to put this line in your every sim file you have.
Okay, it recognized by itself.
Yes.
Because OMS PRJ links to the home, the folder project. You can see in the console.
Okay, it's good.
In the folder we define, yeah, we can find in the right upper folder.
Then we have the start date. So format start date. So the first date in this case is this one.
Start date.
Oh, sorry. Thank you. Then the end date. No, the end date is not required here. We need the time step of the time series. The time step. That is 1 hour, so 60 minutes. The separator. Is the comma. and we need the number of columns variable. One is always one. And then the no value. So format file no value. And here I need of one more bracket to close the first one. And this is the sim file for the data formatter. Okay, thank you. Now we can try to launch this simulation. So
my ex.
sorry. Oh yes, I didn't change the folder. It doesn't work. I can try to run from the console. Okay, there is a problem here. Okay, now I check here if it works. Okay, the Docker doesn't work. We can now try to rewrite the reader component, reader and write simulation. So I open the original one. I copy the first line up to model. And then I start to complete the 3 section components. Here I define the 2 components that I need, the reader and the writer. Then I have the section parameter. So I start with the input file, reader file. It is in the home, data underscore formatted. Then I have the reader id field, that is ID. Sometimes it can be also another value, maybe val, depends on your input file. And we have a reader start. The time step of the series. That is 60, and the no value. And the reader is completed. Now we have to define the parameter for the writer component. So we have the file name of the output file, writer.file. It is in the home, output, data output, CSV. The start date time step.
Yes. No capital.
Oh yeah, thank you. Okay. And also the writer is completed, and now we have the connection section, the connect. So we want that the data that are read by the reader are passed to the writer component. So we have a reader output out data, that is the input for the writer. So writer in data.
Can you repeat what ED
Okay.
parameter.
Yes. When you have your data formatted, you have this line number 5 starts with a string. In this case is ID. Some cases can be val, and it is this string is used by OMS to recognize the ID of your measurement station.
So if you have like 10 measurement station,
you will have ID, comma, comma, and then 10 numbers. The important thing is that this string allows OMS to recognize which are the ID station number.
So as a result, the number of columns
Doesn't matter how many.
so it means you can select like that ID parameter which station you want to use.
Don't know this. You can select the station you.
I mean, if you put just from 1 to 10, for example, so you will necessarily have 10 columns of data, and let's assume you just put 1, 2, and 3. I would use the first 3 columns.
It depends from the shape file. You need to have all the data in the CSV file, okay, and in the shape file you have the ED of your station. If you have 10 columns, but only three ID in your sheet file, the same file sorry, will read only these 3 columns. I answer to your.
Yeah.
And now we can try to run the simulation. Okay, I missed one, 2 brackets at the end. Now we can, for example, modify the data formatted file, and instead of ID, we can put, for example, val. In this case, the sim file has to be modified in this way. Reader ed field, instead of ID, I put val. And it works. So now the output open. In the output, for example, in this case, the writer still write the this string as ID, because the writer component was written to write ID instead of val. But the important thing.
The shapefile field should be named ID, right?
Yes, exactly.